greatest mathematicians of all times. Let us quickly go through this romantic question from a branch of mathematics called analytical geometry. Okay. So in this question here, this is question 7. They say in the diagram below, a circle with center C given by 3 and -1 and a radius of 10 units is drawn. PQR and PT are tangents to the circle at Q. Okay, we have a center here. Let me highlight the center. We have a center. We have a radius here of 10 units. They say PQR and PT are tangent to the circle at Q and T respectively. They say PT is parallel to the x-axis. Here they say C, I think they meant R here, not C, R. R with coordinates K and 21. C and P, these are the vertices of triangle RCP. So yeah, they're supposed to say R here, not C. Then they gave us the distance of QR, which is 20 units. 7.1. We are instructed to write down the size of angle CQR. So PQR is a tangent and QC is a radius. So we know that the radius is perpendicular to a tangent at the point of contact. So it means this angle here must be 90 degrees. So I'll go straight and say CQR, angle CQR is equals to 90 degrees. I can supply a reason. I'll say radius. I'll say radius is perpendicular to a tangent at the point of contact. Radius is perpendicular to a tangent. Then I move right along to 7.2. 7.2. So they say I need to calculate the length of RC, and I must leave my answer in set form. This means that I must not give an estimate or an approximation to the distance of RC. Okay, right. Since CQR is 90 from 7.1, we can easily see that triangle CQR is going to be a right angle triangle, which means I can apply the theorem of Pythagoras. So I'm going to say now in triangle CQR, CR squared will be the longest side since it is opposite the right angle. CQ squared plus QR squared. CR squared is equals to CQ squared plus QR squared. I'll supply a reason there. I'll say Pythagoras theorem. Pythagoras theorem there. Then I'm going to substitute here. CR squared. CQ is going to be 10 squared. Then plus QR will give me 20 squared. And therefore, this will give me what? CR squared is equals to 100 plus 400. And then this will give me 500. CR squared can be expressed as what? As 100 multiplied by 5. Then I will take square roots on both sides. So CR squared. So we know that CR is length. So I don't have to put plus or minus here, like we will normally do when we are solving equations. And therefore, this will give me square root of 100 multiplied by square root of 5. Then this will give me 10 square root of 5. So therefore, this means the length of CR will give me 10 square root of 5 units. This is the length of CR. 10 square root of 5 units in set form, in simplified set form. Okay, then we go to 7.3. 7.3. Now here we know that this distance is 10 square root of 5. So 7.3, they ask me to find the value of K if R lies in the first quadrant. Okay, so now I am going to apply the distance. I'm going to say the square of CR must be equal to the sum of the squares of the difference between the x coordinates of R and C, plus the square of the difference between the y coordinates of R and C. So this will be x at R minus x at C all squared plus y at R minus y at C squared. So here I have square root of 500, which is our CR. Then I square there. There I'll substitute x at R will be k, minus x at C will be 3 all squared, then plus y at R will give me 21, minus y at C will be negative 1 squared. So this will give me 500 here. I'll get 500. Then I'll get k minus 3 squared. Plus, this will give me 22 squared. I will have 500, which is equals to k minus 3 all squared plus 22 squared gives me 484. 484. Therefore, this tells me that k minus 3 all squared will be 500 minus 484, which will give me 16. Then I'll take square root on both sides. Square root of k minus 3 all squared. Now this will be plus or minus because now k is a coordinate. So it can be negative or positive depending on the quadrant. Right, then this will give me something like k minus 3 is equals to plus or minus what, 4. Therefore, k minus 3 will be equals to positive 4. Or k minus 3 will be equals to negative 4. Therefore, this gives me that k is equals to 7 or k is equals to negative 1. So this is what I'm going to have. Therefore, here we are told that k is a point. Okay, they said R lies in the first quadrant. So therefore, this means that the correct value of k will be 7 because this lies in the third quadrant. So this one is not going to be applicable according to the question. So k is going to give us 7. So then we'll come here and write this as what? 7 there. K is going to be 7. All right. Then we continue with the problem. Let me clear some space here. Must I clear the space or what? Let me clear the space. I'm clearing the space here to do the next question. Clear the space here to do the next question. Right, so the next question says to me, I need to determine the equation of the circle with center C and it passes through point Q and T. And I must write my answer in the form. So we know that, okay, this is 7.4. 7.4. We are given the standard equation of a circle. X minus a squared plus y minus what? B squared. It's equals to r squared. We have a center here. Center is going to be, it was given there is 3, -1. And then the radius there was given to be what? To be 10 units. That's the radius. Then I'll substitute this into the formula. X minus 3 squared plus y minus -1 all squared, which is going to give me how much? 10 all squared. Therefore, the equation of this circle will be x minus 3 squared plus y plus 1 all squared, which is going to be how much? 100. Which is going to be 100. So we got the answer for that one. Then 7.5. 7.5, we are told that we need to find the equation of PT. Remember, at the beginning of the question here, we were told that PT is parallel PT is parallel to the x-axis. So this tells us that PT is a horizontal line because the x-axis is horizontal. So therefore, it means the equation of the tangent PT will be y is equals to the y coordinate at t. Okay, so now how do I get the equation of this tangent? Very easy. Very easy. So I am going to construct a radius here like that. So this radius will be perpendicular to this tangent PT at the point of contact. Therefore, that means the coordinates of t are going to be 3 and some y value that we don't know what it is. Now, since this point lies on this circle, I can substitute this point into this equation here and then solve for y. If I do that, I am going to get, remember the equation says x minus 3 all squared plus y plus 1 all squared, which is equals to 100. Then I'm going to substitute this point here. So x will become 3 minus 3 there, squared plus. Then here we will have our y plus 1 squared, which is equals to how much? 100. Therefore, I'm going to have y plus 1 all squared to be equals to how much? 100, because 3 minus 3 will give me 0. 0 squared will give me 0. Then 0 plus y plus 1 all squared will give me 0. Therefore, this will give me y plus 1, which is equals to plus or minus the square root of 100. If I take square roots on both sides, let me take the square root on this side as well. Therefore, this will give me y plus or minus 1, which is plus or minus what? 10. Then I'm going to have y plus 1 is equals to 10, or y is equal, y plus 1 rather, y plus 1 will be equals to negative 10. So therefore, this tells me that y will give me how much? Will give me 9, or y will give me how much? Negative 11. So this one is not going to be applicable, this one, because the tangent is below the x-axis. So therefore, it means the equation of the tangent, it's going to be this line. Therefore, it means PT is defined by the line y is equals to negative 11. That's the equation of PT. That's the equation of PT. Then we move right along to 7.6. We move right along to 7.6. Let's move right along to 7.6. We move right along to 7.6. These problems, mathematicians, they are not as bad as most of us think they are. You just need to practice. You just need to have passion in what you're doing. You just have to develop love. You just have to develop strong feelings for this subject. Then you will be powerful. Simple as that. Let's look at 7.6. Now, we know that this is negative 11. Yeah. Right. Then let's look at 7.6. 7.6, they say the equation of the line PR. Okay, now they say PR is defined by 3y minus 4x is equals to 35. This is what we have there. Then we are asked to calculate the coordinates of P. So the coordinates of P here, mathematicians, it's going to be some x that we must find and negative 3, because P and T lie on the same horizontal line. Remember, PT was given to be parallel to the x-axis. So which means these lines are horizontal. It means anyway along these horizontal lines, the y value does not change. I wrote negative 3 there. I meant negative 11. I'm sorry about that, mathematicians. I meant negative 11 there. I don't know where I got negative 3 from. Negative 11. My apologies. Okay. So now, this point, remember they said the equation of PR. The equation of PR is given by 3y minus 4x plus 35. So P is a point on what? On the line PR, which means this point P with coordinates x and negative 11 must satisfy this equation. So I'm going to substitute and then solve for x. I'm going to have 3 minus 11, then minus 4 times x, which is equal to 35. So this will give me negative 33 minus 35, which is equals to how much? Which is equals to 4x. Then I'm going to add these two here, 35 plus 33. So this will give me 4x is equals to negative 68. It will be negative 68. Then I'll divide by 4. I'll divide by 4. Therefore, I'll get that x is equals to 17. X will give me 17. So let me just check here. 17 times 4 is 68. Yes, x will give you negative 17 rather. Therefore, the coordinates of P, they are going to be negative 17 and negative 11. These are the coordinates of P. These are the coordinates of P, mathematicians. Let's continue. Let's continue with the problem. Let's continue with the problem. So this now will become negative 17. Okay, I have the coordinates here. I'll just write them here. P is going to be negative 17 and negative 11, mathematicians. That's how we do that one, okay? Right, then B, this is 7.6a. Then 7.6b, they say I must calculate the length of PQ. The length of PQ. Remember, we were told that PQ and PT, these are two tangents. They are all from the same point, and they are all tangent to the same circle. So therefore, they must be equal in length. So it means if I can find the distance of PT, and then the very same distance will be the same as the distance of PQ. So I'm going to say here, let me just get back to my original color. So I'm going to say here, PT will be equals to what? PQ. What will the reason be? The reason will be tens from a common point. From a common point. These are tangents drawn from a common point. Right. Remember, PT is a horizontal tangent, which means the y coordinates do not change. Then finding the length of PT, I can ignore the y coordinates and then subtract the x coordinates. So I'm going to have x at t minus what? X at p. So x at t will be 3 minus, and then x at p will be negative 17. And then this will give me 20. Let me just do this here. And then I'm going to say, therefore, the length of PT will be what? 20 units. 20 units. Since PT and PQ are equal in length, since PT and PQ are equal in length, therefore, I'm going to say the length of PQ will also be how much? 20 units. Will also become 20 units. So this is what I have there. This is what I have here. PQ will also be 20 units. Then I'll come and write here. What? Yeah, I'll write 20 here. Remember, this distance is also how much, mathematics? Is also 20, the distance. Therefore, the next question is asking me, let me quickly remove this one. My computer now is becoming very slow now. Computer, come on. People want to pass. People want to go to vets. What are you doing now? Why are you becoming slow now? Come on, my computer. Please don't do that to me. Please. Please. People are waiting to go to UCT next year. Please, computer. Please. Yes, thank you. Please cooperate, my computer. Please, I beg you. Please. All right. So the next question, the mathematician is saying to us, is the area of triangle, QRC equal to the area of triangle QPC? So I'm going to write that one. This is 7.6 what C. I'm going to write it down. So we have triangle QRC and triangle QPC. So to answer these questions, we can easily see that these triangles are congruent. Remember, if this angle here is 90, this must also be 90. Angles on a straight line or radius is perpendicular to a tangent. So you can see that this side is the same as that side. This angle here is the same as that angle there, and then this is a common side. So therefore, we are going to conclude that triangle QRC is going to be congruent, meaning that it is exactly identical to triangle QPC. The reason will be side, angle, side. That's the reason. Therefore, the two triangles will have equal areas. Therefore, the two triangles have equal areas. Therefore, the two triangles have equal areas, because we showed that they are congruent, have equal areas, just like that. Then take your bag and go to University of Pretoria. Then let's look at D. Question D, 7.6D. They say consider the line X is equals to Q. For what values of Q will the line be not a tangent to the circle with center C? So if this is a vertical line, people. X is equals to P. X is equals to Q. It's a vertical line. This is a vertical line. It's a vertical line. It is a vertical line. It's a vertical line, mathematicians. It's a vertical line. X is equals to a constant. It's a vertical line. So it means the value of Q must be chosen in such a way that the line will cross. The value of Q must be chosen in such a way that it is between the x-intercept of this circle. Any number between the x-intercept, any number between this point here and this point here will make the vertical lines to become what? Not to become tangents. Any line between the x-intercepts of this circle will make, any vertical line between the x-intercepts of this circle rather, will make that line to be not a tangent, because it will cross it at 2 points, will become a secant line. So now I need to get the x-intercept of this circle. So to get the x-intercept here, I'm going to do what? I'm going to let y to be 0 in the equation of the circle. If I let y to be 0, remember the circle was what? Was x minus 3 squared plus y plus 1 all squared, which is equals to 100. So I am going to do what? I'm going to make y to be 0 here. If I make y to be 0 here, I'm going to get x minus 3 squared, and then plus 1. Okay, let me say plus 0 plus 1 squared, which is equals to 100. This is what I'm going to have. Therefore, this will give me x minus 3 all squared. It's equals to 99, because the 1 will go to the other side. 99, the 1 will go to the other side. Then I'm going to take square roots on both sides. That will give me what? X minus 3. Let me just show how I take those square roots in case other mathematicians get lost. This will be plus or minus the square root of 99. This is what you're going to have. Therefore, then this will give me x minus what? Minus 3, which is equals to plus or minus square root of 99 is going to be 9 times 11. This will give us 3 square root of 11 in simplest set form. Therefore, x will give us how much? X will give us 3 plus or minus 3 square root of 11. So this means the value of P, if I want the line x is equals to q not to be a tangent to this circle here, it means the value of q, this number must be anything between these x-intercepts. So that means 3 minus 3 square root of 11 must be strictly less than what? Must be strictly less than, okay, I think if I put it this way, it will save me some time. Because, okay, let me just write it. It will be less than Q, less than 3. Then I'll show you later what am I trying to say is square root of 11 here. Square root of 11 here. Then, you see, I must also say that, or I must say, you see, I must say that Q is what? Is less than, you see, 3 minus 3 square root of 11. Move away. What is, you see, oh, this laptop, yo, square root of 11, or Q must be greater than 3 plus square root of 11. But all of this can be summarized by just saying Q is an element of real numbers, but Q is not equals to 3 plus or minus square root of 11. You see, I mean, I wanted to say Q is not equals to plus or minus 3 square root of 11. I must say 3 square root of 11, like that. This is what I'm trying to say. You see, if I write it like this, then it's much more easier and quicker than all that I wrote here. You see, then it's a problem. You see, this is good. I'm saying that Q can be any number other than what? Other than 3 plus or minus 3 square root of 11, because these are the x-intercepts of what? Of that circle. Those are the x-intercepts of the circle. So it means this point here will give you 3 plus 3 square root of 11 here, this point here. And then the other point here will be the 3 minus 3 square root of 11 there. And if your Q is equal to this number, it means the line will go like this here. It will be a tangent. And it will be a tangent. But we want to choose these values of Q so that the line x equals to Q is not a tangent to the circle. Then it means it must be either going here or going there or going here. Then it will not be a tangent. And that can only happen when Q is not equals to the x-intercepts of what? Of the circle. Mathematicians, that's good. So that's how we answer that question. And then let's continue and do the last question, And by the way, this is a question request by a mathematician with the name Mnube. It's a question request, so I'm just quickly helping him. Right, and then 7.7a. Let me just do the last one. 7.7 what? A. They say consider another circle with equation. We are given a circle with equation x minus what? X minus 3. X minus 3. Yeah, this computer. X minus 3 squared plus y plus 16 squared. It's equals to how much? 16. So they asked me to write down the coordinates of the center M. So the center M will just become what? 3 and what? Negative 16. There's the answer. So this is how you easily do these questions, mathematicians. Thank you so much. All the best. Bye-bye.